Hi, I'm Aaron Yurkowicz, a PhD candidate in robotics. And today, I'm going to help you to create technologies, robotic clothing, that helps people to move. So we find sometimes it's hard for people to close their hand, extend their hand, and this makes it difficult to do daily tasks. Some of these can be things like grabbing this water bottle and taking a drink, and then releasing the water bottle. So to meet these challenges for people, what we want to do is we want to create technologies in order to help them move, in this case, their hands. So here we can start with the user. Here's somebody who has their hand normally closed and is trying to grasp a water bottle. What we want to do is create wearable technologies, such as a glove, that will help them to extend their fingers. Here's their fingers, and these are their fingers extended. And the purpose of these technologies are to make a process that currently has a lot of effort and takes a lot of time to do, and instead make the process much easier, much lower effort, and take less time, so that people can carry on with their day. Now these technologies have just a couple components to them, and these components will help the robot to know what the user wants it to do, and then provide the power in order for the robot to make these motions. We can call them sensors. These sensors will detect the human's motion. Then these sensors will tell some kind of energy source how to move the robot. And then you'll have some mechanical components that actually make the robot move and help the person. So these mechanical components then help the robot move. Within sensors, you can break it down into different sensors that you could then use. You could use motion. You could use force. For energy sources, you could think of batteries. So this would be a storage system, or actuators, such as a motor. And then mechanical components, things like the structure, how is it mounted to the person? As well as another area, transmission. How do we make the actuator connect to what's going to pull on the body to help it move? Let's add that one here. Now, within all of these categories, there can be subcategories, such as different materials you might want to use, different electronic equipment. So it's really hard to choose between all of these in making your final design. So here's a tool that you can use as you're designing these technologies to make them more useful to the user. We call it a quality functional deployment, a QFD. There's user requirements or user characteristics. So these would be qualitative things like what the person actually wants it to do or feel on them. So this could be something like stability, so stabilizing the water bottle. It could be something that's easy to put on, so something that slides on very easily, also comfortable, something they've got to wear all day anyway. And then design characteristics. We can think of force, weight, and motion, things that have quantifiable values that are related to the design. So first, we look at these user characteristics, and we want to attribute some kind of weight to them, how important each of these are. We can think first of comfort. They're going to be wearing it all day. It better be comfortable. It should be something that's easy to put on, but maybe they can work around these challenges or if it's a very useful device. So let's give it half the weight. And then stability. It's actually got to do the job. Grab the water bottle and hold it. Let's give that an 8. Then we think about how the force, weight, and motion fit into the stability, easy on, and comfort characteristics. So we can give these all weights based on some small symbols here. 9, 3, and 1. So 9 being very important, 3 being sort of important, and 1 being not very important. Or we can also just leave it blank if it's not that important. So force and stability. I mean, there needs to be the force in order for you not to drop the object. So let's give that a strong weight. The others maybe don't apply as much. For weight, if you want to stabilize that object, you got to make sure it's not too strong that you can't even lift that object up to begin with. So let's give it a medium weight. Easy to put on. And then the main one here, comfort for weight, where if it's kind of heavy, it's going to be heavy on your body. It's going to make your shoulders and elbows start to hurt. So let's make that important. And then motion. Motion, and you need to extend and contract your hand in order to actually stabilize the object. And then the other is not as important for today. Now, when you create this chart, it's important to involve your user when you're actually doing this, so that these make sense to your user. So now we're going to go on to how this chart affects your decision on transmission. So 3 different types of transmission: cables, so things that will pull in order to extend the hand; links, something that's a little bit more rigid. You can think of something with bearings, something with metal components; and something like a fluid, something like a balloon that helps to extend the hand. From our research, we can attribute some values to these options. So I'm just going to fill those in. And now, with these values, we have to figure out what these mean to the design characteristics. The way we do this is we think of the importance of each of these design characteristics. So the importance. And what we do, very simply, is just multiply these numbers by these numbers. 9 times 8, 72. Weight will be 130. And then motion, also 72. So here we see that weight is the most important. So if we look to our transmission options, we can see these ones have the lowest weight. And then we can look to our other options where the cables give a little bit more force than the fluids. So here is a way to know that cables would be a good first option for our transmission. Now we can select options for all the other components and come up with a final design to use with the user, test with the user, and then iterate this QFD. Here's one of the devices we've created. You can slide it on. You can see that it's pretty easy to put on, but not the easiest. Maybe it's not the easiest to put on. We have a battery on here, which we select as our energy source. We have cables in order to pull on the fingers, which we've selected here. And then we've chosen a button as the sensor that will move the robot. So if you see here, you can just click this button and it'll help the fingers close. And then if you click it again, it'll help the fingers open. And once you've tested this device, you can then test it with your daily objects. So here's your water bottle again. Click the button, and you can take your drink. And you can click it again, release your water bottle. Thank you for listening and learning how to create robotic clothing that helps people move.